This question is about period 3 elements. Figure 2 shows the second ionisation energy, so this is when we're going from the already 1 plus ion to the 2 plus ion of some elements in period 3. Draw a cross to show the second ionisation energy of silicon. So the first thing we need to think of is these are actually already the 1 plus ions. We're looking at their second ionisation energy. So magnesium would have already lost 1 electron, and so would be 3s1. Aluminium would end 3s2. Silicon would end 3s2, 3p1. The silicon 1 plus ion would have the electron configuration of aluminium. So actually this is where we're in a new subshell, which is slightly higher in energy, so slightly easier to remove. We've got this pattern of 2, and then this pattern would be 3 for the p subshell. These are the s subshell electrons, the first 2. These would be the p subshell electrons, the next 3. So we're kind of tracking the line back. So we want our cross to track the line back. And if we track it back, our cross would be around here, just below 1600. Because we're going 2 and then a dip and 3. Then there would be another dip because we would get that pairing, and then the next 3 would continue on. So we're looking for this spot here, just below the 1600 mark. Identify the element in period 3 from sodium, so Na, to argon, that would have the highest second ionisation energy. Well, the trick here is remembering that we're talking about things that have already lost 1 electron. And if you remember then that when sodium's already lost 1 electron, it has 1 less shell than all the rest of the period 3 elements. And so sodium is going to have the much highest second ionisation energy because it's already lost 1. Normally, as you go across a period, the one at the end, you'd normally think argon would have the highest, but that would be the highest first. Sodium will, for its second ionisation energy, will have lost the whole third shell, and so its electrons will be much closer to the nucleus. And then it says write an equation for the process, which we already explained above, is where the 1 plus ion loses electrons to become the 2 plus ion. We get our 1 mole of electrons coming off here. Make sure you've put the state symbols on. Explain why the atomic radius decreases across period 3. So, from Na to Cl, there are the same number of shells. With similar shielding. But an increasing number of protons in the nucleus. So stronger nuclear attraction to the outer shell. That's why they're getting a little bit smaller. Identify the period 3 elements from sodium to chlorine with the highest electronegativity. So for the same reasons as above, as there are more protons in the nucleus, the power of the nucleus to attract the pair of electrons in the covalent bond increases. So chlorine would have the highest electronegativity. Phosphorus, which we need to remember is P4, burns in air, oxygen, to give phosphorus 5 oxide. So you might be tempted to think that if this is a sort of a +5 oxidation state and oxide is 2-, that the formula is P2O5. You need to remember that the molecular formula of phosphorus 5 oxide is P4O10. So then we would balance that like this, and we've written our equation.